All right, I should be live. Good morning, good morning, good morning, good morning. Hope everyone had a great weekend. We are live, and we'll just see who else shows up. Let's see, got two of you in here. Welcome, welcome. Have to test the whiteboard. Let's see what's going on today. What should we test it with? Ooh, maybe this. I hope I didn't use this word, but why not? All right, so the board is live. Let's see who's out there. Good morning, Sarah. Good morning. So the board is live. When you can, make sure that you test the link and see today's message. You can just write it in. Oh, I am now live. I don't know why my face comes in and out. It's funny. That's right, Sarah. Iced coffee. Okay, so we'll wait. Okay, let's see. Trying to find a good gift. That's a good one. All right. Yeah, I was running a little behind today, so I didn't post my daily gifts. You guys like that? Hopefully, you also noticed that I changed my icon. Yes, Eleni, iced coffee. Café me pagos. All right? Café me pagos. Am I right? Good morning, Liana. To be more specific, Eleni, Café me pagos Horis Gala. Horis Gala. Horis Akari. Mono. Mono signomi. Mono Mavro. Did I pass today? Did I pass my Greek 101? I hope I did, Eleni. I hope I didn't disappoint. Hey, Josh. Welcome. Welcome. Just waiting for a few more of you to come in. Okay. Only five of you here today. So it's interesting this week. From what I've read from the Academy News, I suppose, is that this week is supposed to be a week where you're making up work. Is that correct? What's your favorite genre of music? Rock. Definitely rock and roll. I do like instrumental rock too, progressive rock. I like some new age stuff, some classical stuff. I like everything. I like everything. International music, like you name it. I like official soundtrack music, video game music, uh, movie music, just music that moves, something that, you know, if you're listening to, if you're doing something and then you hear a song and it makes you stop. That's what I want. That's what I like, where you can't focus other than on the music. Whatever that genre may be, that's what I like. But it tends to be rock, distortion, heavy, you know. I like melodic vocals though for the most part. Screaming is kind of cool. It depends. I like it more live than listening to it. Everyone's different. All right, so we have about 9 of you here. So let's see. Where do we begin? So I did grade your work, your projects. I graded, I think, almost all of your homeworks. I just have to transfer your homework grades to Jupyter. So that's number 1. Number 2, the project grades are up. That I posted on Jupyter, so you should see that. So all of that is live. I made clarifications on the review sheet, so hopefully you saw that also. And so again, the exam is going to be this Friday. The exam is going to be this Friday. The exam format. So I think it's going to be timed. So that's number 1. I'm going to give you a window of time to complete it. This is not going to be like a 24-hour window of time. I'm probably going to give you about 2 hours. So I'm reading here. Facts, music that has meaning to me on a personal level is my favorite. The most common genre is alternative. That's awesome, Josh. Thank you for sharing that. Thank you. So going back to the exam. So I kind of made mention of this in the comments, but I'll mention it again. So the exam is going to be timed. I think I'm going to have maybe between 5 and 10 questions. I haven't decided yet. It's all going to be short answer. I'll submit it, let's say like at 8 a.m. This is what I think. I think, so I'll start the exam at 8 a.m. Are we going to be submitting our review sheet work on Google Classroom? So how I've done in the past, so I'm not sure if you noticed, but whenever I assign review sheet, I don't think I check the work for review sheet. That I left the responsibility on you to do, right? So if you don't do it, it's really going to impact you in a bad way when it comes time to take the exam. So I kind of left that on the students. So it would behoove all students to do it, right? Because it's good practice. However, if I'm going to review all of the work, that I don't believe so. That you can complete. I told you exactly what to focus on. I'm going to give you the solutions to that probably a little bit later today. I should have them, so this way you can prepare. So going back to the format of the exam. Format of the exam. It's going to be all short answer. I'm pretty confident that I'm going to give you 2 hours to do this exam. 2 hours. And it'll be take home, kind of like implied, right? So I think you're going to have between 8 a.m. and 10 a.m. on Friday. I'll post the exam at 8 a.m. And the exam will close at 10 a.m. Between 5 and 10 questions, you'll probably have at a minimum 5 to answer. And I think given the type of question, you should all be done within an hour. This is what I'm thinking. So we'll discuss that a little bit more later when the class fills up with more students. But that is what I believe will be best for us. Because I could give you, Lumen Learning? That I could do. But I don't know. Like it's just like, you input answers, and then there could be, I want you to be, working with each other. But that I feel, I don't know, it's a little harder to control. But I think with this, it's timed. You finish the work, you take a picture, and you submit it to me. So now here's the other, good morning, Kyle. Now here's the other thing too. So this is where integrity, right? So taking the picture of the work, there's more at risk here because I'll be looking and I'll be making sure that your work is your work and it's not that of a neighbor. So you have to be very careful here with integrity. There were already some integrity issues with the project, so I don't want to really get into that, but uh, I want there to be no integrity issues with this exam. 2 hours between 8 a.m. to 10 a.m. You should be finished with it in an hour. I'll give you an extra hour to polish it up. I don't know how many questions you're going to have to answer exactly, but you will have a choice of at least 5. What happens if someone can't make it to the exam in time? I'm certain I will. But in the case something happens to me or someone else, um, so here, like, I have, so how do I put this? How do I phrase this? Okay. Let me figure out the best way. Give me like 10 seconds so I can come up with a good response to this question. Right? Because there's always going to be a reason. There's always going to be an excuse. And it could be valid. I'm not taking away from the fact that your excuses are legitimate. But there's also, on the other end, uh, the possibility of it being illegitimate, or just a flat out lie. So I'm giving plenty of notice, right? You do have to show up to class at 9 a.m., right? You have been, for the most part, students have been regularly doing this. So to give that window of time between 8 and 10, and where you could finish the exam, if you start at 9 and then you complete it by 10, it's doable. I'm going to make sure of it. So that's why I'm giving you double time, right? And the only thing is this, would I give it between 9 and 11? Yes, I would, but then that goes outside of the time that we're supposed to meet. And I definitely don't want to impede or take away time from your other classes. So that's why if I started earlier, you can, show up to class at 8 a.m. and then you'll have until 10. But you should be done within an hour. Any other questions related to the exam? So again, just to repeat it very quickly, exam will be on Friday, start at 8 a.m., give you 2 hour window. I'll probably give you, I'm thinking 10 questions, you pick at least 5. And you must show all work. You take a picture of the work, you put it all together, you upload it to, I'll have an exam portion on the Google Classroom so that you submit the work and then that'll be it. Yeah, I really want you guys to do well. It's not meant to be punitive. It's really flexible. You'll probably, to have this opportunity again, I hope that this doesn't happen again. It's challenging for everyone. So given that we're in this circumstance, being flexible, most of your teachers are being flexible, so take advantage of that flexibility and, thrive in it. Thrive in this environment because it's somewhat easier to thrive here, I believe, than outside or in the regular brick and mortar. And everything's at the comfort of your home. So, any questions before I move on? Any questions? All right, I like the comments. Drove to the beach and had lunch in the car. That's awesome, Irene. I'm just reading your comments quickly. I watched a lot of movies. That's good. I ordered new clothes. That's nice, Harpreet. I just hope that one day everything opens up fully and then you can show that off. Dahlia got a new laptop. Very cool. Nice. Finished a TV show. I hope it was a good one, Cindy. I cooked something new for the first time, Brittany. Ooh, I hope it came out good. And I wonder what it is. I got enough sleep. I've been sleeping too, about 7 hours. Very unusual for me. I think I'm averaging about 7 hours every day. Highly unusual. I'm the type of guy that sleeps about 4 or 5. I found diamonds in Minecraft. I think that's cool. I don't know what that is, but I hope that's like a thing and it's positive and you're now number 1 in your group in Minecraft world. I ate my favorite dinner. I ate gummy bears. Very cool. I watch movies. Which ones? I watch my favorite shows. Which ones? Went outside for the first time in forever. I hear that, Maria. I drove to Manhattan with my family. That's nice. I got really good night's sleep on Saturday. Hey, if anything, sleep up. Sleep up. That's all I can say. All right, so let's move along. So the solutions have been posted to the homework. I made a formal post for that homework yesterday, so hopefully you're able to finish it. It should not have been taxing at all. It should have been a very simple assignment. So that is the story there. So we're going to move along with angles. So the board is working, the live stream is working, and that's it. Here we go. So standard position. So we're back to angle measurements now. We looked at degrees and how to convert from the subdivisions of degrees, right? So if you have some decimal or fractional value, we expressed it as minutes and seconds. But now we're going to look at the other terminology that we looked at on Friday, and that deals with standard position. Right? I think we looked at initial side and terminal side. So the beginning is that ray where the angle begins, and then the terminal side will move in a counterclockwise manner, and this will show or display a positive degree of rotation. So an angle is in standard position if its vertex is at the origin and its initial side lies along the positive x-axis, so as displayed here. So vertex origin, and then the ray, which represents the terminal side, will move into different quadrants, either quadrant 1, 2, 3, or 4. Let's see. Are you going to go over some review questions tomorrow? I will. So, okay, to answer some questions here related to that. You know, it's interesting. At some point in, so this is now talking about Microsoft. Microsoft is awesome, by the way. I keep, plugging this, but at some point in interactions, you're going to be able to raise your hand virtually. So right now, I read the comment, but at some point, it's going to be like flashing red, so that indicates that you're raising your hand. So it's funny. Anyway, yeah, tomorrow's going to be just review. I'll be around digitally to support that, and then you'll have your exam on Friday. Okay, so standard position, we're good there. So these angles that are in these quadrants, we call them quadrantal angles. So angles in standard position whose terminal sides lie along the x-axis or y-axis, but more specifically, when they're going in increments of 90, like 90, 180, 270, we call this quadrantal angles. So just additional vocabulary. So coterminal angles. There's going to be a lot of vocabulary today. So we looked at angles in standard position. We looked at quadrantal angles, now coterminal. So again, a complete rotation of a ray results in an angle measuring 360 degrees. So then going back to that x-axis. So initially where the initial side becomes the terminal side. Think of it that way. So by continuing the rotation, angles of measure larger than 360 can be produced. Such angles are called coterminal. So as an example, if you look at the graphic there, you have 60 degrees. So I'll show that on our whiteboard. So here we have our coordinate plane. Right here we have x and y. So imagine here we have an angle. Here is this blue. This is the, oh, it's so terrible. So this blue represents the initial side, right? So I can rotate all around, right? So I'm going to go up to here, let's say. So this red, it represents a terminal side. So it terminates. So we have the red and we have the blue. Initial side versus the terminal side. So if we look at where the red stopped, or where the terminal side is, it could represent 60 degrees. Could. But if I go all the way around, and then I add another 60 degrees to it, so I made my complete rotation about this vertex, about the origin, and then I add another 60 degrees to it, that leaves us with 420 degrees, but we could say that the coterminal angle of 420 is 60, if that makes sense. So again, So if we read this definition, by continuing the rotation angles of measure larger than 360, we're going to call this coterminal angle. So although we have a 420 degree angle, it also could represent a 60-degree angle. And if you look here, this other example, 110 degrees, right? So now we have this terminal side in quadrant 2. We're looking at the second example here. But if we keep rotating repeatedly over and over again, right, we can get to 830 degrees. But what's going to happen is that we've rotated X amount of times about the origin, so that when we get to that angle of 830 degrees, it's really the same as an angle of 110 degrees. So basically the thing to think about is this. If you have 830 degrees, how many complete rotations of 360 occurred? So that's something to think about. Clearly one, high probability of two, but probably not three, right? It's probably 2 point something. And what is that point? It's the fractional amount of 360. How many exactly? Should be 110 out of 360. So something to think about. So let's look at this example. So you should have the handout. It's the same handout from the last time. It's just continuing down. And we're looking at this next example here. It says, find the angle of least positive measure, coterminal, right, with an angle of 908 degrees. So that's the challenge here, right? So you have a 908 degree angle. Where is this? So that's number one. Number two, what we need to figure out is this. How many degrees or how many rotations actually happen? So how many complete? So what do you think we could do if you think about it? So again, if you think about this, with this 360, the easiest thing to do would be to divide it into 908, right? So then you can at the very least get an idea. I mean, you should be able to tell right away how many complete rotations you have, right? More than one, more than two, because right, if you multiply 360 by 2, it's still not 908. But then when you get to 3, it's not going to happen. So we're going to be left with 2 and change, right? So at the very least, you know that you're going to have 908 degrees. And what you want to do is then subtract the difference between the two full rotations of 360 degrees. And then you're left with a value. So if you do this, you'll have the following. So again, here, taking a look. So something to consider also, when you have this angle now, which is going to be 188 degrees, you have to think about where it ends or where it terminates, right? So it's terminating in a quadrant, but we have to be specific with that quadrant. So again, quadrant 1, when you reach that quadrantal angle, it'll be between quadrants 1 and 2, so it's 90 degrees. You go to 180, you're going to be in between quadrant 2 and 3. But now that we're at 188, clearly we're going to be in quadrant 3. So this angle, which is 188 degrees, it's going to end up in the same location as a 908 degree angle. So we call it coterminal. So again, an angle of 188 degrees is coterminal with an angle of 908 degrees. So I hope that's clear, or a little bit clear. So I guess to say it in English, you're going to have this potentially large angle, potentially, because it could also be negative, and we may look at an example or two with that. So you just have to find out where this angle would be if it were between, let's say, 0 and 360, something to think about. So if we look at this second example, now look, that's what I was telling you. Now we have negative 75 degrees. So think about it this way. right? Negative implies clockwise rotation. So if our terminal side again here, we are here, this is terrible, I know. You would think even in a digital board, maybe my handwriting would be better, but it's not. That is awful. I'm so sorry that you have to look at that. But I think you kind of know where I'm going with this. So this black, supposed to be a ray, is the initial side. So if we're going in a clockwise manner, so we have to go, now because clockwise, again, that implies negative. So it's about negative 75 degrees. So we're going to be here, right? So it's negative 75 degrees. But now the question is this: what is the equivalent angle if we were to rotate this in a counterclockwise motion, right? Where does the terminal side end? Clearly it ends in quadrant 4 if you go clockwise, and you're not moving that much. You're only moving by 75 degrees. But in the counterclockwise world, or where you have positive degree, you're moving more. But the question is, what is that coterminal angle? And if you look, what you would do essentially is you would take 360. Yeah, you can add negative 75, or you would subtract 75 from it. And then that would give you your coterminal angle. So in other words, an angle of negative 75 degrees is coterminal with an angle of 285 degrees. So I want you to try number 3. So this is negative 800 degrees. So I want you to try that. So I'm going to give you about 2 minutes. Explore that question. See if you can figure out that angle. So again, you can use the two examples that I have there to give you some idea. It's basically a blending of those two ideas. So again, you're trying to figure out the coterminal angle for negative 800 degrees. So think about the position, think about how you're moving, whether it's clockwise or counterclockwise, and always try to get into the habit of identifying the quadrant where the terminal side resides, or where the terminal side ends up. So again, where is negative 800? So please chime in when you figure it out. I'd love to see your responses. So while you go over that, are you a fan of my profile picture? The Memoji version of Alarcon? Is that a yay, a nay? Should I go back to just having it MA or whatever it was? Like the letters, the boring letters? Does it look like me, in other words? Should I create a poll? All right. So a negative 800. I don't have anyone responding. I need at least one input, someone. What is negative 800 degrees? I need the coterminal angle. Yay. Oh, thank you, Brittany. Negative 80, quadrant 4. All right, let's hear some more responses. So we end up with negative 80 in quadrant 4. Anyone else? I'm a fan of your profile pic. Only one other teacher I have also has a unique one, and it definitely looks like you. Good. Now, let's see that angle. Let's see the angle. So we have only one response. We have about 16 of you in here. Still waiting. Thirty more seconds, then I don't want to take up any more of your time. Where are the responses? Me waiting. That's how I look like right now in this chat. Waiting for like a message to pop up. Eyes fixated. All right, no time. So, let's see. Here we go. So, find the angle of least positive measure coterminal with an angle of negative 800 degrees. So, here's the thing. So, when we do this, we want to find the positive angle. Positive angle. So, we're going to investigate what Leah said in a second. So, if we look, here's the thing. So, negative 800 degrees, it's definitely not going to be complete 3 rotations, right? It's not. But since it's negative, let's assume that 3 full rotations took place, because then that will allow us to subtract from the degree measures that represent 3 full rotations. So 363 times is 1080 or 1080 degrees. And if we take away 280 degrees from that, then we're left with a positive coterminal angle. So in looking at what Leah said, it's correct to some extent. It is, because negative 80, that would be an equivalent angle, right? Because it will terminate in quadrant 4. It'll have the same terminal side. But if we go back to the definition, right, we want, or not so much a definition, but really what the question is asking for. Find the angle of least positive measure. Positive measure. So that's the whole thing, positive. So I'm in agreement with Leah, but we had to find the positive one. So here, to just kind of like shortcuts, to find an expression that will generate all angles coterminal with a given angle, add integer multiples of 360 to the given angle. For example, the expression for all angles coterminal with 60 degrees is 60 degrees plus n times 360. So this is kind of a shortcut. So again, this is how it would work if you were to apply it. But I like the idea. It's essentially the same thing, thinking about the number of complete rotations, whether you're on the positive end or the negative end, and then making adjustments. So if you think about it, these angles that you're identifying, to some degree, they are a remainder. So think of it that way, a remainder of 360 degrees. So typically, as I always say, you would have time to try all this stuff, but given the time or the lack of time in this environment, you can just take a look. Maybe some of you went ahead. I'm happy if you did. Great. This would be the solution. You can take a picture of that. So let's move along. So the one with the CD player, I mean, you can take a look at it here. It's a little bit more involved, but here again, you can take a picture and time permitting, this is kind of an extension. It's not something that I'm going to necessarily ask. So again, if you want a real thorough or if you want to test your understanding of this, this is one good way. But again, I'm not going to necessarily ask this type of question on an exam. So moving along. So now we looked at in the circle, angles of positive measure, negative measure, standard position, coterminal angles, counterclockwise, clockwise. So all this stuff is happening, but at the same time, we could also look at degrees, right? Because we've been measuring in degrees, but we have another way of measuring angles, or in this case, how we work within a circle. Because again, if you think about an angle, it's just a span, right? It's a span of an arc. But an arc can be represented basically how it's highlighted here. So if you look at this picture, and I can show you here in the whiteboard. So if you think about an angle, so I'll draw an angle, right? So if I make this arc from here to here, from these 2 points, that's really what we're measuring. So that could be measured in degrees, but it could also be measured in something called radians. So a radian, it's actually kind of simple concept. So the way to think about it is this: how many radii are in a circle? So in other words, let me make it even a little bit clearer. So how many radii in a particular circle can you fit along the circumference? So that might sound like what? But here, let me just draw it very quickly. Do I have circles here? I hope I do. Maybe. Is that it? Yeah. Let's assume this is circular in nature. So again, you're on the board here. So basically, if you think about it, here you have a radius, right? So the question is, how many of these radii, right? Because radii in a circle, they all have the same length, if you think about it. So if I make the circumference, so let me just highlight this. So if I make part of the circumference the length of a radius, right? So this is supposed to be a green highlight. So sorry. So this green highlight here, this arc, is the length of a radius. The question is, how many radii will fit along the entire circumference? So that's the question, number one. Number two, you actually know this answer. Because if you say that your radius is 1, right? Let's just assume that your radius is 1. Everything here is 1. You know that the length of a circle, or the circumference, right, is represented by 2 pi r. Hopefully this is coming back to you. So that if you have a radius of 1, your circumference will measure 2 pi. But pi is about, what, 3.14? So if we simplify this, it's about 6.28, roughly. So if you think about it, how many radii fit on the circumference of a circle completely? About 6 and change. So what's the change? About 0.28. So if we were to sketch out, like here, like how I exaggerated this green radius on the circumference, right? I would fit 6 of those perfectly, but then I'll have a little bit of leftover space. And that leftover space is about 0.28 because pi is about fractionally 0.14, right? Or 3.14 if we think about the whole picture. So I don't want to confuse you too much, but basically here is the conversion from going to pi to radian measure, and from from going from degree to radian measure, and from radian measure to degree. So multiply a degree measure. So how this comes about, I'll do this very quickly, because if we think about it, 2 pi is a complete circle, 360 degrees. It's the entire circumference, right? Which is what we discussed before. But if I divide this by 2 as an example, then I have pi is equal to 180 degrees. So this is basically our scale, or you can think of it as our rate, a ratio, or a proportion that we're going to use eventually. So it depends on how I express it, right? Pi to 180 or 180 to pi. So the scenario to the left will give us radian measure. The scenario to the right will give us degree measure, right? So multiply a degree measure by pi divided by 180 to simplify or to convert to radians. Multiply 180 divided by pi to convert back to degrees. So the whole thing is working with the denominator. If you have pi in the denominator, you can eliminate it when you multiply something that has pi in it. If you have a degree in the denominator, then you can get rid of degrees if you're multiplying some angle measure with that particular ratio. So if we look here as an example, so we'll do this quickly. So we have 45 degrees. I'm going to go over one quickly. I know we're running out of time. So 45 degrees. So if I want to convert that to radians, I'm going to want pi as part of my answer. I'm going to divide that by 180 degrees. Or in other words, I'm going to multiply 45 by pi divided by 180. And if this is done, it becomes pi divided by 4. So in other words, think about it this way, right? Think of it this way. If pi equals to 180 degrees, right? If you chop it by quarter, right? By 1/4, you'll have the same measurements. So 1/4 of pi, which is 180 degrees, is 45 degrees. Similarly here, if you look at the next example, you have 270 degrees. We'll worry about the negative in a second. So we have 270 degrees. So you want to convert this to radians. So we know that we have pi divided by 180. But when we multiply all of this, it will be 3/2 pi radians. So think about it this way, right? So if you know that 2 pi is equal to 360 degrees, right? So you can use this measure. Again, it could be, hold on here, something to think about, right? So there's a couple of ways that we can look at this. You know, we can divide this by 2, and we have pi divided by 180 degrees. Right? So if we think about how this is all working, right? So let me just clarify this because I don't want to confuse you any further. So using this ratio, or this rate, if you will, pi to 180, 2 pi to 360, we're basically trying to figure out how much, right, or what portion of the circle we have in terms of radian measure. So if you think about it this way, if you know that 2 pi is a complete circle, then what we have here is 1.5 pi, right? Because it's going up by 90. So if you think about it, at 180, you have pi. But if you add 90 to that, you get 270, or 1.5 pi. So I'm just trying to get you to understand the logic as to how this conversion is happening. But on this note, I will stop here, all right, because we kind of went over time. And all of you, thank you for sticking around. So moving along. So just to sum up, we went over a few things today. We went over converting. Just right here, this last thing, we converted from radians to degrees. I'm going to leave the conversion of degrees to radians, actually we just did, sorry. We did degree to radians. I'll leave the radian to degree measure to you, but that's not going to be tomorrow's homework. That I'll have assigned for some point next week. The homework today, again, I'm not going to count it as a formal homework. It's just going to be more for you so that this way you're preparing, is the review sheet. I gave you all the details of the questions that you should be focused on. It's all in a comment section. Were you able to see that? So that's number one. Were you able to see the comment section where I told you what pages to focus on and what questions on the pages to focus on? Did you see that? Can someone please confirm that? Anyone? I just need one person to confirm. So again, if you look at the review sheet for exam 2, I hope you saw that. I posted a comment. Yeah, I saw the comments. Yes, thank you so much. Do you get notified? Do you get an email that says Alarcon posted something? I just want to make sure that that's happening. Yes, we see it. Great, great, Kyle. Thank you. But my question is that when I make a comment, I post, does an email go out to you saying, hey, Alarcon posted something? Do you get that notification? Again, the question is when I make a comment or a post, let's say something that's attached to a homework, not for me. Okay. All right, yeah, so it's not everyone, but I'm glad that you saw it. So I may have to make a comment then or do something in the stream. So I'm notifying you now. I'll probably post it on the stream so this way you can all see it. This way there's no confusion. But for those of you, we get notified when you post, but not comment. All right, great. That sucks. But thank you for sharing that with me. So I'll post it on the stream shortly, but it's there now. If you go into exam 2 review sheet, what you need to prepare for, I don't want to take any more of your time. Yes, if you turn on notification, you get the emails. Yes, so you should do that. So if you want to be notified by me, you should do that. Believe me, I'm not posting so much content all of the time, so I'm not going to annoy you. So fear not. It might be helpful. But I'll post it again on the stream. You'll have it there. We'll focus on that tomorrow. We're not going to go over every single question, but I'll give you the solutions. But based upon our conversation tomorrow, it will shape how the exam will look like. All right, so on that note, I have to run. More meetings to attend. Busy day. I hope you guys have a productive day, that it's not too overwhelming, and that we can see each other again tomorrow with, everything that we discussed today. Hopefully everything works out so that tomorrow's conversation will be even better. So on that note, I am logging off. Again, I could be reached all day through email. You want to message me on the stream, that's fine too. I'll be around. Have a great day, everyone. I'll see you tomorrow morning.